All right, guys, let's add to our new notes again. So this time we're going to talk about solving absolute value inequalities. So we'll do that on 78 and 79. And then there will be one more. I know it's so tempting to just be like, oh, we're done. We got one more thing. Okay. So if we turn to 78 and 79, I actually want to start, on 79. And do a little reminder for you guys up here, and we'll try a couple. So, solving absolute value inequalities. Okay, now hopefully we remember the inequalities are like greater than or equal to, less than, or less than or equal to. Now, basically, when we're solving an absolute value, we want to solve it the same way. So our first step in solving an absolute value was to get the bars alone. So like get rid of, add or subtract. That's like over there with the bars. Then we want to get rid of multiplication or division, which might be like sitting in the front of the bars. So you're going to get rid of those. Once your bars are alone, we always make two equations after that, although these ones will be inequalities. And so the thing is, we got to think about those two equations now, because if you're looking at a less than or equal to versus a greater than or equal to, you will break them up, the same way, but what happens is you get a compound inequality because you have two inequalities. We've done these before where if I'm looking at two inequalities and I'm solving them, then sometimes the lines come together and connect and I get an and inequality. Or sometimes the lines go opposite of each other, like one goes one way, one goes the other, and that's an or inequality. So the way that I kind of remember, these are less than. So if you kind of say it like you're Southern, they're less thans. So we can remember that this less than or equal to symbols will always make an and compound inequality, which the and compound inequality looks something like -2 is less than x, which is less than 4, or something like that. And graphing wise, when we graph that, we do like -2, open circle, 4, open circle, and ands always connect. Okay. Now again, when we add the absolute value bar, you'll kind of see how that works too. With the other ones, these are greater than, but if you kind of say it weird, greater than, you'll remember greater than is going to make an or inequality. Now, when you had an or inequality, they were just separate. So it was kind of like x is less than -2 or x is greater than 4. Because those are kind of going in opposite directions. Being less than -2 or being greater than 4 are going opposite ways. So we got -2. Oh, let's do an equal sign just for funsies, because then we got closed circles. Less than is this way. We got our 4, closed circle, and greater than is that way. So the or inequalities always go away. Our and inequalities always come together. Now, one other little note. So we make our two equations. When we do, if you remember, one is positive and the other is negative. And we got to remember, when we make a negative thing with an inequality, you got to flip that sign. So like either less than or greater than. So let's try a quick one here, and then maybe I'll make a separate video. Well, yeah, we'll try two quick ones here, and then I'll make a separate video for the other page. So example 1 if we have something like absolute value 2x plus 1 minus 3 is less than or equal to 6, first, always, we're going to get the bars alone. So these bars are not alone. There's a minus 3 over there. I'm going to add that 3 away. So then we'll have absolute value of 2x plus 1 is less than or equal to 9. And now we make our two equations. So the moment I go to make my two equations, I think about it. And I'm like, is it less than, so an and, or is it greater, so it's an or? And right now what I'm looking at is less than. So this is going to be an and inequality. And so when I make my two equations, I still write the first one the same. Oop, I forgot my other bar. So 2x plus 1 is less than or equal to 9. And my other equation, remember the inside stuff stays the same. So still 2x plus 1. But now I got to make the 9 negative. So since I made a negative, that's where I got to flip that symbol. Okay, so not less than anymore, greater than. And that's why it's so important to decide up here, like, am I looking at a less than or is it a greater than? So we decide before we split, okay? Because whenever we split, we're going to have both. Alrighty, now we just go through and solve each one. So I'd subtract the 1, 2x is less than or equal to 8. Divide the 2, so x is less than or equal to 4. And over here, subtract that 1. So 2x is greater than or equal to negative 10. Then divide the 2. So x is greater than or equal to negative 5. Now, a couple things. We always got a graph with these inequalities, but also I kind of want to rewrite this so that it does look like an and inequality. So it always goes small x large. So we'll have the smallest number, negative 5, then x, then the 4. And guys, there are always going to be less than symbols here, even though this one is greater than. When we write an and inequality, there are always less than symbols. And then finally, when I go to graph it, we'll have negative 5, and it'll be a closed circle. 4 will be a closed circle, and they will connect to each other because and always connects. X is bigger than negative 5, but smaller than 4. All right, one other quick one to try. And then, like I said, I'll post another video of page 78. Let's say we have absolute value 2x minus 4 greater than or equal to 2. All right, so first step is get those bars alone. Well, my bars are alone. There's nothing over there with them. Okay, like there's nothing outside of them. It's just all the stuff inside of them. So right off the bat, I can make my two equations, but I want to think about, is it a less than or a greater? And this one is a greater. So we're looking at an or compound inequality. So I make my two equations. The first one is identical, or the second one, the inside part stays the same. Then I got to change the number to negative, and since I changed that negative, I got to flip that sign. So now it's less than. Okay, then we just solve each one. So I'd add my 4. So 2x is greater than or equal to 6. Divide the 2, so x is greater than or equal to 3. Or add that 4 over here, and so 2x is less than or equal to 2. So x is less than or equal to 1. So like if you really think about that, x is bigger than 3 or smaller than 1. Like that's definitely a or. It's got to go one way or the other. So on 1, we're going to have a closed circle, and x is less than that. And then on 3, we got a closed circle, and x is greater than that. There's no sort of like fancy rewriting of an or. An or symbol or an or statement just always has the word or in it. But an and statement we can rewrite and make it look nicer. So it's kind of the smallest and the biggest. What's at the end and what's at the beginning. Alrighty. More examples in the next one.